Okay, so for ETC, there are three important virulence determinants. One is the heat labile enterotoxin. One is the heat stable enterotoxin. The other is the colonization factor antigen. Colonization factors. Okay. So for heat labile enterotoxin, okay, it is a so if it's heat labile means it's sensitive to heat. So it will break down if you cook your food thoroughly. Okay. Heat stable means it's stable. It will not break down even if you cook it up to 100 degrees Celsius. That's the differences. So for heat labile enterotoxin, it has 5 subunits, 5 B subunits for binding. Okay, and then one A subunit in the middle that will activate the cyclic AMP. It will activate adenylate cyclase, which will produce a lot of cyclic AMP. The cyclic AMP will cause a lot of your electrolytes to go into the intestinal lumen. And because of osmosis, your body will also start losing water into the intestinal lumen. Okay, that's why you have watery diarrhea. Okay, so that's the main the action of how the heat labile enterotoxin works. Okay, so later you'll see that other bacteria also use similar toxins, also have similar toxins. For example, cholera toxin also adopts a similar pathway. For heat stable enterotoxin, it stimulates the cyclic GMP. So the mode is different, okay, but it also promotes the loss of electrolytes and then later on loss of fluid into the intestinal lumen. So for ETEC, for disease to occur, you need minimum CFA. Okay, you need colonizing factor antigen. Okay, but without the CFA, the disease doesn't occur because, as I mentioned, for disease to start, there has to have attachment. Okay, and without CFA, there is no attachment. The bacteria will be just flushed out from the system. Entero-invasive E. coli. This is very similar to shigellosis. Later on, you'll learn about Shigella. Very, very similar, but milder. Not as serious as Shigella dysentery. Not as serious as a actual Shigella infection. Okay. Main characteristics are it does not ferment lactose. It is non-motile. So this is very, very unique because E. coli is known to ferment lactose. E. coli is also motile. Okay. But somehow in EIEC it has lost this ability. So the reservoirs are only human and higher non-human primates. The infective dose is 10 power 6, also still very high. So the infection is via M cells. M cells are specialized intestinal epithelial cells in the ileum. Okay, what the M cells do is they'll absorb through transcytosis, they'll take in the pathogens and pass it to the macrophage for them to kill the pathogen. So this is very natural. So the EIEC will be absorbed, will be taken up by the M cells through transcytosis, but then the EIEC is able to overcome the macrophage. Okay, uh, it actually is able to escape and induce macrophage cell death. That's why you get diarrhea, because your body defense system cannot kill the pathogen. Okay, so so this is transcytosis. Okay, so the M cell will transfer the EIEC to the macrophage, but the macrophage is not able to kill the EIEC. Therefore, it escapes and invades neighboring cells. Okay? And when it does that, it starts killing the other cells. Okay? That's why you will have massive inflammatory response. You will have tissue lesions. Okay? You have tissue lesions that will also bring about mucus and blood in the diarrhea. Okay, but so all these infections have varying degrees, whether it can be serious or less serious. It also depends on your immune system, whether you are healthy or whether you are susceptible immune compromised. So if you're healthy, then it will be self-limiting. Okay, because this is still milder than Shigella. Okay, so it still exhibits less virulence relative to Shigella. So these are the main virulence determinants. But what you should know is it doesn't employ the ST or LT toxins, but instead it has the Shigella enterotoxins. Destroys colonic tissue. For biochemical identification, so inability to ferment lactose, absence of motility. It also has H2S production. Why is this important? Because the Shigella species doesn't produce H2S. So this will allow you to differentiate EIEC from Shigella. So most of these are not suitable for normal biochemical testing for identification. That's why the phenotypes are not so useful. So most of this screening are done for research purposes, not routine. As I mentioned, mild to moderate, self-limiting. Okay? And the severity of the disease depends on the age of the patient. Okay, all this have to be taken into account. Next is EPEC, enteropathogenic. So this is the leading cause of infantile diarrhea. Effective dose is also very high, mostly profuse watery diarrhea, or sometimes bloody, but mostly just watery diarrhea. So this one has the adherence to enterocyte. They are EPEC adherence factor. So it has a very interesting enterocyte adherence factor. Okay. What this does is it will cause the cell loss from the villus tips, and then it will attach itself to the top like this. Okay, so the villus is destroyed with the E. coli attaching to the top. So this is very uh, of diagnostic value in order to know that this is EPEC. Also, no LT or ST involved, able to form attaching, effacing lesions on the surface of the intestinal epithelial cells. So this is the one that are the attaching, effacing lesions. So it attaches, it clumps. So if you look at the dark portions here are actually clumps of E. coli. Okay, so they clump together, localized adherence. They clump together and then they adhere to the cell. So these are all done on tissue culture cells. Enteroadherence E. coli. This is persistent diarrhea. It's a non-bloody diarrhea with mucus. So it has the aggregative adherence fimbrate and also these toxins, enteroaggregative gigatoxins. So EAC forms biofilms on the intestinal mucosa. Then the bacteria will adhere to each other. So you see the pattern here. If you look at the picture carefully on the slide, the E. coli is stacked along each other like a thread. So stacked brick appearance. So the EAST toxin is important for EAC. Enterohemorrhagic E. coli. Part of it is also known as Shiga toxin producing E. coli, also as verotoxin producing E. coli. So this is probably the most famous E. coli that you will hear in the newspapers because these are the ones that cause fatality. People actually die from this. Hemorrhagic colitis, copious bloody discharge. So if you look at it, the infective dose is actually very small, 10 to 100. For most people, it resolves after 1 week. You will have diarrhea, fever, abdominal cramping, and vomiting. However, fatality rate is 5 to 6%, an increase to 31% for elderly patients, with 13% long-term kidney damage. So if you are elderly, you are susceptible because your immune system is weakened. Okay. There are several serotypes for EHEC. Serotyping means you use serology to type it. But the best known is 01577. Serology typing, you'll see O, H, and K. O stands for somatic antigens, which means the antigens on the cell. Okay, on the cell. H stands for flagella antigen. Okay, H stands for flagella. So the antigen, they target the antigen on the flagella. K stands for capsular. Okay, so most of the time, if you use serology, serotyping, you will see what kind of antigen it is targeting. So it is also considered to be closely related to Shigella and it has recently acquired Shiga toxin genes from Shigella. So the toxin itself, when it's released from the bacteria, is internalized by the cells, and then the toxin destroys the cells. Okay? And because the toxin is still present, the toxin is, after the destruction of the cell, the toxin continues to destroy neighboring cells. Copious bloody discharge, a lot of blood, because the toxins are very effective. Okay? A lot of blood. It is not as invasive as Shigella, but it is the toxin that is important here. It is the toxin that causes the most damage. So it is found in the intestinal tracts of many animals. So with undercooked ground beef, raw milk, vegetables, all these are possible risks. They can bear the bacteria can grow in it. For initial isolation, we use the sorbitol McConkey agar. Not the normal McConkey agar. In sorbitol McConkey agar, the lactose is replaced by sorbitol. E. coli, normal E. coli ferments sorbitol. EHEC doesn't ferment sorbitol. So you'll get colorless colonies. So colorless colonies on sorbitol McConkey agar is presumptive of EHEC. Okay, and then once you have the colony, you can carry out your serotyping. And finally, you have your EAEC, specifically adhering E. coli. So look at this. If you look at this picture here, the cells are diffused. Okay, that's what it means. That's where it gets its name from. Okay, so diffuse adherent. So although it binds, it doesn't clump together. It diffusely binds to the microvilli. Okay, so it has this surface fimbriae F1845 that is characteristic of DAEC. So this one you can determine from the PCR. Okay, from PCR. Yes, it causes watery diarrhea and treatment is rehydration. So when you look at all these 6 types, you need to know that ETEC is traveler's diarrhea, EIEC is a milder form of shigellosis, EPEC is infantile diarrhea, EAEC is persistent diarrhea, EHEC causes the hemolytic uremic syndrome, and DAEC is the diffusively adhering E. coli. Okay, then look at the sites of colonization. Most of it is small intestine, except for EIEC, which attacks the colon, and also EAC. EAC is both colon and small intestine. Then some of the, whether you have profuse watery diarrhea, whether you have hemolytic uremic syndrome, okay, and whether you have bloody diarrhea. So as I mentioned, the adhesion is important. So this one is CFA mediated. Colonizing factor antigen is important for EC. Then EIEC is non-invasive. Then EPEC has the attaching and effacing, the one that the E. coli stack on the broken villi. The attaching effacing lesion, A/E lesion, that's specific for EPEC. Then you have EAC where you have the stacked brick, where the E. coli is stacked from the biofilm that they form. And then DAC is diffusively adhering.